In case if you don't remember what the z-test is, please go back and watch that lecture before working on this one. Today we are going to see the t-test. The t-test is used when we have to test hypothesis on a population mean for a population whose variance is unknown. Well, the variance is sigma squared. But when we introduce the t-test, we simply say that the t-test is used when sigma, which is the population or the true standard deviation, is unknown. All right, do you see the difference between the z-test and the t-test? Let me repeat. The z-test is for known sigma. The t-test is for unknown sigma. Read the given questions carefully. If sigma is given, go for the z-test. If sigma is not given, go for the t-test. I'm repeatedly emphasizing this because there are many students who tend to forget when to use the correct test. If you do a z-test for a place where the t-test is required, or vice versa, you will lose all the points. So be careful. Also, please note that in this lecture, I will directly use the testing concepts described in the previous lecture on z-test without reintroducing all of them from the beginning. For example, when I say the p-value, I assume that the students basically know what it is. When I say alpha, you should know what it is very well by this point, since we have seen it several times, including the confidence interval discussions. So the stuff won't be explained from zero in this lecture, just an advance warning. On the other hand, if you completed the homework last week, you should be in a very good shape to quite easily understand this lecture. All right, let's begin the t-test. Like I said earlier, we use the t-test for testing the hypothesis on a single population mean when the population standard deviation, or the true standard deviation, sigma, is unknown. Since sigma is unknown, what we do is we use the sample estimate of the standard deviation, which is given by the letter S. You already know how to find the sample standard deviation. If you don't remember the equation, you at least know how to use your calculator and also the software MS Excel in order to find the standard deviation S. Well, finding the standard deviation will not be too critically important for this, because even though you can use the equation and try the traditional method of hand simplifications, statistics is a real-life matter. We always encourage to use technology for obtaining answers without spending too much of time on useless hand calculations. Of course, your calculator TI-84 has a shortcut for the complete t-test. If you use that, you will not need to find the standard deviation separately. We can use the t-test for all three forms of hypothesis: left-sided, two-sided, and right-sided tests. I'm not going to introduce these things once again, since we already defined them in the previous lecture. Please remember, mu0 is a given constant in the question, which means a numerical value. You have to compare the population mean mu against that given numerical constant mu0. Testing procedures. With the t-test also, all three forms of testing procedures are available. We can do confidence intervals. We can do test, statistic, and critical value approach. And also we have the p-value method. All forms of t-test, we have to use the student's t-distribution. Note that the student's t-distribution, or simply the t-distribution, is not a single specific distribution. It's a collection of distribution based on the degrees of freedom. The degrees of freedom equals n-1. You already know it. You saw the t-distribution in at least 3 previous occasions. First time was during Instructors Chapter 2. Second time was during the discussion on constructing the two-sided confidence intervals. And then we once again saw it in Instructors Chapter 3, one-sided confidence intervals. Anyway, since the t-distribution depends on the degrees of freedom, the critical values are not fixed, even for the same alpha of 5%. The critical values should be found separately for each question using the degrees of freedom and the given alpha. Well, alpha is 5% or 0.05, which is fixed, but the degrees of freedom will not be fixed. Don't ever use the Z critical values 1.645 and 1.96 ever in the t-distribution based calculations. All right, let's look at the confidence interval method. This should be intuitive to all the students by this point. Only difference is we do t confidence intervals this time because we are now discussing the cases where the population standard deviation or the true standard deviation sigma is not given. We have three forms of tests. We will quickly visit one by one. For all these tests, the null hypothesis H0 is of the form mu equals mu0, where mu is the population mean, for which we need inference, and mu0 is a given constant. For left-sided tests, i.e. tests of the form, the alternative hypothesis H1 is mu lesser than mu0. What should be the type of confidence interval we need? We will do a lower T confidence interval. We have to see if mu0 is inside of the confidence interval. If so, we accept the null hypothesis H0. Otherwise, we reject the null hypothesis. Please note that accepting the null hypothesis or rejecting the null hypothesis is only an intermediate step in the process. Don't stop there. You have to interpret the test result in the context of the problem given. Interpretations will be similar to the z-test interpretations. Please don't forget the interpretations. Not providing the correct interpretation will cost you most of the points allocated for the question. For a right-sided test, i.e. a test of the form alternative hypothesis H1 is mu is greater than mu0, we have to do an upper T confidence interval. Once again, the test procedure is to see if mu0 is inside of the confidence interval. If so, we accept the null hypothesis. Otherwise, reject the null hypothesis. And again, don't forget to interpret the test result in the context of the problem given. And for two-sided tests, i.e. tests of the form whose alternative hypothesis H1 is mu is not equal to mu0, we do a two-sided T confidence interval. Test procedure stays the same. We have to see if mu0 is inside of the confidence interval, and if it's inside, we accept the null hypothesis. Otherwise, reject the null hypothesis. Once again, don't forget to interpret your test findings. All right, this stuff is very straightforward. All right, let's now look at the second approach of hypothesis testing, the test statistic critical value method. Once again, we are working on the populations whose standard deviation, sigma, is unknown. Therefore, we are using the sample standard deviation, which is given by the lowercase s. Therefore, we find a t-test statistic. The t-test statistic is given by x bar minus mu0 all over s over square root of n. You don't have to remember this equation either. There's a calculator shortcut for that. But I wanted to show you the equation that the calculator uses to find the t-test statistic. Always, for the t-test statistic critical value method, the first step is to find the test statistic. After that, we can do the tests. But also keep in mind that the significance of the t-test statistic depends on the degrees of freedom, where the degrees of freedom equals n minus 1. All right, let's see how can we use the t-test statistic for the three forms of hypothesis tests. First, we will look at the left-sided tests. For these, we have alternative of the form mu lesser than mu0. To test the hypothesis, we need the t critical value so that we can compare the test statistic and decide what to do with the null hypothesis. I have written the t critical value as t sub left alpha df. This means I need the left-sided t critical value for type 1 error of alpha with the corresponding degrees of freedom. How can we find this t critical value? Well, this is not the first time finding the t critical values in this class using the t distribution, but we will see it again. Here is the t distribution. As you know, the t distribution is also similar to the standard normal distribution or the z distribution. So the t distribution is also a nice bell curve, which is centered at 0. Only difference is that the t distribution has got somewhat thicker tail probabilities compared to the z distribution. As the degrees of freedom increases, those tail probabilities will become approximately equal to the z distribution probabilities. All right, for the t critical value, let's assume that the distribution shown on the screen is the t distribution with the required degrees of freedom. For left-sided critical value, we keep complete alpha on the left tail. Then this is the t critical value for a left-sided test. Can you still remember how to find it using the TI-84 calculator? What's the left-sided t critical value for a test which uses alpha equals 5% and a sample of size 10? Pause the video for a minute and see if you can answer that question before listening to my answer. All right, the answer is, since the sample is of size 10, the degrees of freedom is 10 minus 1, which is equal to 9. Then you can go to the calculator TI-84, go to distributions, select number 4, inverse t. Then you have to find the area and degrees of freedom. Of course, degrees of freedom is 9 for this example. What should be the area? Remember, in the inverse t function of your calculator TI-84, area is always the area to the left, which is directly the given alpha for a left-sided test. Of course, for this class, alpha will always be 5%. Therefore, for a left-sided test, the area should be 0.05. All right, these entries should give you negative 1.833 as the critical value. Likewise, you can find any critical values. Once the critical value is known, the rejection interval for the left-sided test is the interval that corresponds to the x values of the shaded region, which means from negative infinity up to the left-sided t critical value is the rejection interval. For the example discussed earlier with degrees of freedom equals 9, the rejection interval will be from negative infinity to negative 1.833. All right, then if the test statistic is on the rejection region, we reject the null hypothesis. Otherwise, the null hypothesis is accepted. And accordingly, the outcome should be then interpreted in the context of the problem given. Similarly, for a right-sided test, which means the alternative hypothesis is of the form mu is greater than mu0, we will need the right-sided t critical value. I have written it as t sub right alpha df. Well, writing it like that is not required. I just draw it as that. For the right-sided tests, we need to keep the complete alpha on the right tail of the t distribution with the corresponding degrees of freedom. And then you can read this critical value. How can you do it using our calculator? When alpha is 5%, what should be the area? Like I said earlier, the area should be the area to the left, which means the area should be entered as 0.95. What should be the t critical value for a right-sided test for alpha equals 5% and sample size is 15? You may pause the video, find the answer, and come back to compare it with my answer. All right, to find the answer, you have to go to distributions, select number 4, inverse t, then the area is 0.95, degrees of freedom equals 14, and that should give you 1.761 as the right-sided critical value. All right, then the rejection region should be from the right-sided t critical value to positive infinity. For the example discussed earlier, the rejection interval will be from 1.761 to positive infinity. If the calculated test statistic is in the rejection region, we reject the null hypothesis. Otherwise, the null hypothesis is accepted. Let's say for the example discussed earlier, the test statistic was found to be 3.6. Then, since the rejection region is from 1.761 to positive infinity, we reject the null hypothesis. If the test statistic was 0.5, then we have to accept the null. Once again, don't forget to interpret the test results. Interpretation should be after the step of your decision on the null hypothesis. Interpretation should be only about the fate of the alternative hypothesis as a result of your findings of the test. All right, for a two-sided test, which means when the alternative is of the form mu is not equal to mu0, we are going to have two critical values. Half of alpha is kept on the left tail and the other half of alpha is kept on the right tail of the t distribution with the corresponding degrees of freedom. And then these two values are the two critical values. Note that they are symmetric around 0. Therefore, it suffices to find just one of them, flip the sign, and you get the other one by symmetry. For example, what should be the two critical values for a two-sided t-test if alpha equals 5% and if the sample size equals 12. We can go to distributions of your TI-84 calculator, select number 4, inverse t, and I will find the left critical value. For that, the area should be 0.025 because we enter only half of alpha for two-sided tests. Degrees of freedom equals 11 because we had a sample of size 12. This should give you negative 2.0099 as the left-sided critical value. Well, let's just go for two decimals, negative 2.01. Then by symmetry, the right-sided critical value should be positive 2.01. Then we get the two rejection regions. Negative infinity up to the left critical value is the first part of the rejection region, and the other part of the rejection region is from the right critical value to positive infinity. So if the test statistic is going to be on one of the two rejection regions, we reject the null hypothesis. Otherwise, accept. And don't forget to interpret the test findings in the context of the problem given. Don't forget that the interpretation should be about the alternative hypothesis. All right, then we will quickly look at the p-value method also and then discuss an example. All right, so here is the p-value method. The p-value is also straight away given as a part of the t-test procedure in your calculator. However, I will show you how to compute the p-value using the test statistic. Knowledge on how to compute the p-value using the test statistic will be important for your exams. All right, to compute the p-value without using the calculator's output, first we will need the t-test statistic. All right, let's assume that this is the t-distribution with the corresponding degrees of freedom. We will now see how to find the p-value for the three forms of tests. For left-sided tests, the p-value is the area to the left from the test statistic. We already know it from last week. The test statistic is most likely a negative value for a left-sided test, unless the question is super silly. For example, if the sample mean is 12, if somebody asks if the population mean could be lesser than 10, it's a silly question in statistical hypothesis testing. For such questions, you may get a positive test statistic, but you're not going to see that kind of questions in this class. For example, if the sample mean is 8, in that case, I will ask, do you have evidence to conclude that the population mean could be lesser than 10? All right, for such natural left-sided testing, the test statistic should be negative. The p-value is the area to the left from the test statistic. How can you find it? Say, for example, you have to do a left-sided test. The test statistic is negative 1.85. And the sample used was of size 9. What should be the p-value? To answer that, you have to go to distributions, select number 6, TCDF. Then what should be the lower limit? Since we need the area to the left from negative 1.85, the lower limit should be negative infinity. Simply enter something negatively large. For negative numbers, don't use the subtraction symbol. If you use that, you'll get an error. Negative symbol is the last row, third white key, left of enter key. All right, then the upper limit is negative 1.85. We said the sample was of size 9. Therefore, the degrees of freedom is 8. This should give you a p-value of 0.0507. Please make sure to try these calculations yourself and see if you can get the same answers. For right-sided tests, the test statistic is most likely a positive value, and the p-value is defined as the area to the right from the test statistic. So what should be the p-value for a right-sided test if the test statistic is 2.15 and the sample is of size 10? Once again, you have to go to distributions of your TI-84 calculator and use number 6 TCDF. Your answer should be 0.03002. Well, for the critical values, if you go for 2 decimals, that should be enough. And then for two-sided tests, we have to be careful. The test statistic could be either positive or negative, but we will need both values. That means if the test statistic is positive, we will also need the negative value of the test statistic and vice versa. Let's say, for example, the test statistic is positive as shown. We will then need its negative value as well. The p-value will be the summation of the two areas shown. You must compute the area to the right of the positive test statistic plus the area to the left of the negative test statistic. Well, these two are equal in size. Therefore, if you compute just one of them and multiply that by 2, you should get the p-value. All right, for a two-sided test, what should be the p-value if the test statistic is 1.89 and if the sample is of size 14? Your answer should be 0.0813. All right, as you know from last week, no matter whether your test is left-sided, right-sided, or two-sided, the decision criterion based on the p-value stays the same. Reject the null hypothesis if the p-value is lesser than alpha. Alpha is always 5% or 0.05 for this class. And accept the null hypothesis if the p-value is greater than alpha. All right, we finished the theoretical background on all three methods. Let's apply them in an example. This is example 20.3 from your textbook. To investigate the water quality on August 8, 2010, Columbus dispatched 2 water samples at 20 Ohio State swimming areas. Those samples were taken to laboratories and tested for fecal coliform levels, which are E. coli bacteria found in human and animal feces. An unsafe level of fecal coliform means that there is a higher chance of disease-causing bacteria are present and more risk that a swimmer will become ill. Ohio considers it unsafe if a 100 milliliter sample of water contains more than 400 coliform bacteria. Here are the fecal coliform levels of the 20 samples. The data are given. Part A, write down the null and the alternative hypothesis to be tested. All right, we will let mu be the true mean fecal coliform levels. We have to compare it against 400. The underlined keyword is more than. Next to that, we have 400. So the mu0 value is 400. And this is a right-sided test. Please note that you must write the null and the alternative hypothesis completely as shown. Definition of mu is required. H0, 2 dots or semicolon, then the statement. And H1, 2 dots or semicolon, then its statement. Writing the null and alternative hypothesis scientifically correctly is very important. All right, this step should be clear. All right, we will keep the null and the alternative hypothesis on the screen as we move on to the next questions. Question B. What's the type of statistical test procedure that should be used to test the hypothesis? Explain. We have to go for the t-test because the population standard deviation, sigma, is not given in the question. Actually, when there are no past data for a long period of time, there is no way to estimate the sigma. So the t-test, which is used for unknown sigma, is the most useful form of hypothesis testing for a single mean. All right, part C, construct a 95% confidence interval. Test the hypothesis using the confidence interval. Interpret the test result clearly. You already know how to compute the confidence interval. This is a right-sided test. Therefore, we will need a 95% upper T confidence interval. The calculator will only do two-sided T confidence intervals. Therefore, we construct a 90% two-sided T confidence interval and then replace the upper limit with positive infinity so that we have a 95% upper T confidence interval. In case if you need a refresher on one-sided confidence intervals, please watch Instructors Chapter 3 again. All right, let's go to the calculator. All right, here's our calculator. The data set is given for this question, so we have to first enter the given data set. So I will go to Stat, Edit, number 1, Edit, and then hit Enter. And I'm going to enter the given data set into the list L1. 160, 40, 2800, and so on. I will pause the video now and enter the complete dataset and come back. All right, I entered the complete dataset. Now I need to construct a 90% two-sided t confidence interval. For that, I will go to Stat, select Tests, and then I have to select number 8, t interval. Input method is data. Select data and hit enter. The list is L1 because I entered the data into the list L1. Frequency is always equal to 1. The confidence level. For this time, I need a 0.90 confidence level because I need a 95% upper confidence interval, for which we first construct a 90% two-sided t-confidence interval. Select calculate and then hit enter. All right, so here is the 90% two-sided t-confidence interval. The lower limit is 773.63 and the upper limit is 1598.9. Therefore, the 95% upper t-confidence interval is from 773.63 to positive infinity. Clearly, 400 is not inside of the confidence interval. Therefore, we reject the null hypothesis. This should make sense. The entire confidence interval is greater than 400. In fact, the confidence interval is an interval estimate on the population mean. So there is absolutely no way we can think that the mean could be 400 by looking at this confidence interval. Clearly, the true mean should be greater than 400 according to the confidence interval. All right, since we reject the null hypothesis, how can we interpret the test findings? Rejecting the null hypothesis means our data support the alternative hypothesis. So we say that we have statistical evidence to support the alternative hypothesis. Well, we have to mention the probability used, which is 95%. Also, the alternative hypothesis should be written in words so that someone who is not familiar with the statistical terminology can understand. So we say we have statistical evidence to conclude with 95% probability that the true mean fecal coliform levels are unsafe. All right, the next question. Test the hypothesis using the test statistic critical value method. Do you get the same answer as the confidence interval method? This is a right-sided test, and we have 20 data points. This means for the critical value, alpha, which is 5%, should be kept on the right tail of the t-distribution with degrees of freedom equals 19. Then you will see that this critical value will be 1.729. You already know how to find the critical values, so I will skip showing the calculator steps for that. All right, then the rejection region will be from 1.729 to positive infinity. If you calculate the t-test statistic, it should be 3.2948. Okay, let's go to the calculator and see how can we calculate the test statistic from the entered data points. I have to go to Stat, select Tests, and then select number 2, t-test. Hit enter. Then we have to define the input method. Input method is data because we entered our dataset into the list L1. Select data and then hit enter. And then we have to define the mu0 value. For this question, the mu0 value is 400. The list is L1, frequency is 1. And then we have to select the correct alternative hypothesis. Selecting the correct alternative hypothesis is extremely important. If you did not select the correct alternative hypothesis at this step, your p-value will be incorrect, which will affect your conclusion based on the p-value method. All right, for this question, the alternative hypothesis is a right-sided alternative. Therefore, I have to select the third one, mu greater than mu0. After selecting that, make sure to hit enter. If you forget to hit enter, the correct alternative will not be permanently selected. Skip color and select calculate and then hit enter. All right, here's the calculator's output. Make sure to check the first line of the calculator's output always and see if it exactly is the alternative hypothesis that you need to test. All right, you can see the t-test statistic in the second line and the t-test statistic is 3.2948. And it's clearly in the rejection interval from 1.729 to positive infinity. Therefore, we reject the null hypothesis. That means we get the same conclusion as part C. Interpretation stays the same. we have statistical evidence to conclude with 95% probability that the true mean fecal coliform levels are unsafe. All right, part E. What's the p-value for the test? Test the hypothesis using the p-value. Do you get the same answer as the confidence interval and the test statistic methods? No new calculations necessary. The p-value is given in the third line of the output of the test procedure of your calculator, right here. The p-value is 0.0019, which is clearly lesser than 0.05, the alpha value. Therefore, also we reject the null hypothesis, because we said the null hypothesis is rejected whenever the p-value is lesser than alpha. Interpretation once again stays the same. We have statistical evidence to conclude with 95% probability that the true mean fecal coliform levels are unsafe, or in other words, are greater than 400. All right, I will stop the lecture at this point for the class of today. Thanks for your class participation. Have a nice day.